Welcome to Electricity and Magnetism, Part 1, Introduction. In this section, we're going to look at the very most basic things that generate electricity and magnetism. We're going to look at matter. Number one, something you've heard time and time again in countless number of science classes. Matter is made of atoms. Number two, atoms are made of electrons, protons, and neutrons. Again, something you've heard over and over again. Number three, electrons have a charge of -1 or -e. Either way they're written is acceptable. 4, protons have a charge of +1 or +e. Here's where we lose some students. Remember that the magnitude or the size of the charge of the electron and proton are equal, but they are opposite. Number 5, neutrons are neutral and do not have a charge, hence their name, neutrons. 6, protons and neutrons are tightly bound in the nucleus and cannot be removed by ordinary means. That means they're there to stay. Electrons orbit the nucleus and are not as tightly bound. 8, electrons can be removed by the addition of energy in the form of heat, friction, or light. When we say removed, we mean removed from the atom. Example, shining the correct color light on a metal will cause it to eject electrons, and this is known as the photoelectric effect. Number 9, in normal matter, the total number of electrons is equal to the total number of protons, so there is no net charge. So if we have 1,000,000 electrons with a -1 charge each and 1,000,000 protons with a +1 charge each, you add that together and you get a net zero charge. 10, if electrons are removed from an object, there are now more protons than electrons, so it has a positive charge. Removing electrons generates a positive charge. If electrons are added to an object, it has more electrons than protons, so it has a negative charge. Adding electrons produces a negative charge. Charge is conserved because it is carried by electrons, which are matter. And matter cannot normally be created or destroyed, so charge is not created or destroyed. And when we say the charge is carried by electrons, we're going to always assume in these presentations that the electrons are the objects that are moving to carry the charge. Remember we said the proton is tightly bound in the nucleus and not really free to move around. 13, when charged objects are brought into contact, the electrons flow from the one with the greater negative charge to the one with less negative charge. Example, a ball with a -50 electron charge is brought into contact with a ball with a -100 electron charge. What is the final charge of both balls? What's merely the algebraic average of the two charges? So -100 plus a -50 charge, it gives us a -150 charge. Divide that by 2 because there are two objects. And we get a -75 charge for each object. And let's move this so we can see what's going on a little better. In this example, the electrons flowed from the object with the -100 E charge to the object with -50 E charge. This gives each object the lowest electrical potential energy. Electrons went from where there were more negative charge, -100, to where there were fewer, -50. Because the electrons have like charges, they want to repel each other, so it requires energy to keep them together in the same spot. Let them spread out, they then have the least amount of energy possible. Example, an object with a +100 charge is brought into contact with a +20 charge. What is the final charge of the objects? Well, here you have 100 plus 20, because plus 120 charge, divide by 2. Each object ends up with a plus 60 charge. Now, just because each object has a positive charge doesn't mean electrons won't move between them. So here you see how the electrons flow, so the charge is distributed even though both objects have a plus charge. 15, electrons flow from a less positive charge to the more positive charge. And each one has a lower potential energy, as we discussed before. Like charges repel, unlike charges attract. Something learned many, many times. I've heard many, many times. When there's a collection of like charges, energy is needed to hold them together. Why? Like charges repel. The closer the charges are, or the more charges there are, the more energy is needed. Makes sense. If I have 2 electrons and I need to force them together, it takes X amount of energy. If I have 1,000,000 electrons and I'm forcing them together, it's going to require even more energy because there's more repulsion. Okay, this is an introduction. I hope it helped. If something's not clear, please feel free to leave a comment. If you want something expanded, please feel free to leave a comment there too.